Good day all, welcome to my lessons, and I believe this is my first tutorial with respect to the new WASSCE syllabus, sorry. And physics is one of the most simplest subjects, and I believe if you put more time and focus with dedication, I believe you'll be able to be a very good person in physics. So some of the things we are going to consider, like I said, these lessons are purely in accordance with the new WASSCE syllabus. You see, so the topics are drafted directly how the syllabus is structured. So the first topic within given for the syllabus for the senior secondary school will be physical quantities and units. But these physical quantities and units, I simply call it as the language of physics because this is the backbone of physics. Without this, you will have some challenges in physics. So just after the learner have gone through this video, this tutorial, there are certain things the learner should have learned. One of those things, the learner will be able to define what is physical quantities. The learner will be able to differentiate between basic quantities and that of derived quantities. The learner should be able to define or differentiate between scalar and vector quantities, and as well as give examples in each of basic, vector, scalar, and derived. Yeah. So the second point, what is physical quantity? What is physical quantity? Physical quantity is anything that we can either measure or we can either do by calculation. You see, anything that we can either measure or do by calculation referred to be physical quantity. For an example, if you have consider a pen or a rod or a building, or let's say this can, if I consider this can, there are certain things we might need here. You might want to say you need the mass of this can, or you might want to say you need the volume of this can, or you might want to say you need the height of this can, or the length, or whatever dimension. So in this case, so taking note of the volume, the mass, the density, or the weight of any of this is what is simply referred to as as physical quantity. So physical quantity is anything that we can either do in two things. Either we measure it or we calculate it. So some of the examples of physical quantities, with like the ones I've just listed, we have mass, the amount of substance, length, luminous intensity, thermodynamic temperature, and current. Those are some of the examples of physical quantities. So moving forward again to the next point, we have types of quantities. Basically, we have four types of quantities. The first type of quantity here is the basic or fundamental. The other type of quantity, we have the derived quantity, we have scalar quantity, we also have the vector quantity. So if we consider the basic or fundamental quantity, a quantity that we cannot get from any other quantity. So those quantities which you cannot obtain from any other quantity, you refer them to be basic or fundamental quantity. Some examples of this, we have the length, we have mass, you see, we have luminous intensity, we have the temperature or thermodynamic temperature, we have the amount of substance, we have time. These are some of the examples of basic or fundamental quantity. The other one again we are going to consider the derived quantity. Derived quantity is any quantity that we can get directly from the fundamental quantity. These quantities are purely obtained from the fundamental quantities. But with regards, before we go to the derived quantity, from the examples I've listed, which are the fundamental, those seven, we have three main ones. Those are the ones mostly used. Which are they? We have the length, we have mass, and we have time. Why are they used? Because if you consider like speed is distance divided by time. So speed is there, so distance is therefore is coming directly from the fundamental, and also time is also coming from the fundamental. You see, and if we also consider again density, density is mass divided by the volume. Where do we have mass? Mass is coming directly from the fundamental. So any quantity which is derived from other quantity, we refer that to be derived quantity. So in this case, these three main basic fundamental are mostly used are mostly used by the derived quantities. So that's the reason we consider them to be as the three main fundamental. So suppose you're asked to give the three main fundamental quantities, you should be able to list the time, the mass, and as well as the length. So if we move to the other types of quantities, we also have derived quantity. As I was saying, derived quantities are quantities we obtain directly from the fundamentals. Some of the examples, we have pressure, because pressure is defined as force all over area. And force can also be expressed in another way, which is the mass times the gravity. Where do we have the mass? Mass, we have it directly from the fundamental. So therefore, pressure is a derived quantity. We also have area. Area can be expressed in terms of square, length by length, in terms of a rectangle, length by breadth. So those two quantities, length or breadth, are directly coming from the fundamental. So we refer them to be derived quantities. So we also have another quantity, which is scalar quantity. Scalar quantity is a quantity which only has magnitude but no direction. The magnitude there can either be expressed in terms of length, or in terms of modulus, or in terms of height, length, because it tells us about space. You see, why direction, it tells us about an angle. You see, some of the examples of scalar, we have mass, we have time, we have charge, current, you see. So those are some of them. And we also have energy, volume, you see, efficiency, density. So all those, we refer them to be scalar quantity because they only possess magnitude without direction. So we consider the other type again, which we refer to as the vector quantity. Vector quantity possesses the two qualities, which are magnitude and direction. It possesses those two qualities. Some examples of this, we have moment, we have momentum, we have electric field, the gravitational field, the magnetic field, impulse. So you see, so all those are examples of vector quantity. So if we consider the other subtopic, which we refer to as units, which is a key area in physics, because when you measure anything, you have to indicate the unit. If the unit is not there, so that value is not a quantity. Since it's not a quantity, so it's just a number. So in this case, if we have 5, 5 is just a number. But the moment you write a letter in front of that number, it remains a quantity, and it tells you which type of quantity is that. For an example, let's say we consider we consider 5 kg. So the kg there is simply means it's a unit. So therefore, the 5 kg becomes a quantity. And which type of quantity simply means the mass, because kg is measured by mass. So therefore, 5 kg is a quantity called mass. We also have 5 joules. The joules there in front of that 5 is a unit. And which type of unit it simply means is the force. You see, so therefore 5 joules is a quantity, and that quantity is telling us about force. We also have like 5 newtons. So N there is a newtons, and newton is the unit of force. So therefore 5N is the force. So therefore units are purposely there to identify which type of quantity is this. You see, so units are placed in front of numbers to tell us which type of quantity is that. So in that regards, we have two types of units. We have the basic units and as well as the derived units. What do we mean by basic units? A unit which you cannot get from any other unit. Example, let's just consider the fundamental quantity, because fundamental quantities and basic quantities are somehow similar. The only difference is fundamental are mainly if fundamental quantity tell us the quantities, while the fundamental unit tell us the units. So like for the fundamental quantity, we have 7 fundamental quantities. The first one is the time. Time there is a fundamental quantity. So therefore, the unit of time here is second. So therefore, second is an example of basic or fundamental unit. We also have the mass. Mass is a fundamental quantity. And what is the unit of mass? It's kilograms. So therefore, kilograms is the unit of fundamental. A kilogram is unit of mass. So that mass is an example of fundamental quantity. So therefore, kg is an example of fundamental unit. Similarly, we also have thermodynamic temperature. and that unit is Kelvin. So Kelvin is an example of fundamental unit, and so on. Or we can also consider the mole is also a fundamental unit. Kelvin is also a fundamental unit. We have meters, we have ampere, we have kilograms, seconds, and as well as Kelvin. So all these are examples of fundamental or basic units. So moving forward again, we consider the other type of unit, which is the derived unit. Derived units, as I said, are units we obtain directly from the fundamental. So any unit which we get directly from the fundamental unit, we refer them to be derived unit. For an example, if we consider speed or velocity, the unit is meters per second. So therefore, meters there is coming directly from the fundamentals, as I said earlier on. And the second is also coming from the fundamental. So therefore, meter per second is derived. We also have newtons, we have watts, we have joules. We also have meters per second square. You see, so meters there is coming from the fundamentals or the basic, and also second is also coming there. So therefore, these units are all formed from the derived units. So I think this is the end of the first lesson or the first lecture for the new curriculum. Thank you for watching. So stay tuned. So the next tutorial is going to be dimensional analysis. So this is going to be the next tutorial. So thank you for watching. Stay blessed.